Hello, my name is Marc Austin. I'm founder and CEO of Hedgehog. This is The Hedge, where I talk with industry leaders about AI and AI infrastructure. AI promises a lot of benefits. It also has a lot of risks along the way. So part of this conversation is about how do you hedge the risks and reap the benefits. So on the show today with me today is James Kelly. He's VP of Market Intelligence and Innovation at the Open Compute Project, working with technology leaders in the community and augmenting the foundation's directional strategy, innovation efforts, and marketing. His contributions to the OCP proceed from over 2 decades of experience in technology engineering, product management, and marketing. Prior to working at OCP, James was a product management senior director at Juniper Networks, leading teams responsible for its AI cluster solution, cloud-native products, and automation tooling in the data center and cloud business. In the past, James was also a tech researcher, software developer, interesting one I find, hedge fund founder, and executive technology consultant. So welcome to the show, James.
Hey, thanks for having me, Mark.
It's a really impressive resume, and you're now at the Open Compute Project. A lot of people have never heard about OCP. Can you give us an idea what it is and why somebody would leave a perfectly good job at Juniper to go to OCP?
Yeah, absolutely. So I was trying to expand a little bit outside of networking. Obviously, there's so much going on with AI, and that's revolutionizing everything in the data center infra space and the data center physical space as well, frankly. So the network is super important. I'm sure we'll get into that for AI clusters, but it was an opportunity for me to have a different perch across a wider set of infrastructure and the entire solution of the data center rather than just staying focused on the network. But I obviously bring my network expertise with me to OCP. There's a lot of new projects, new work streams inside of the OCP community. And so I'm helping to, foster those, move them along, if you want to say. Obviously, there's a plethora of neoclouds, or some people call them neoscalers, that have kind of started up, and we're trying to welcome as many of those. So I wear a lot of different hats in the small, 20-odd person staff of the foundation, but I'm one of the technical folks there.
So how was the OCP formed? Like, what was its origin story?
Yeah, good question. I mean, for those people that don't know the OCP, kind of going back to 2011, 15 years ago, it was formed by, Meta, at that point, Facebook, and another, Intel, handful of companies that kind of came together to do open source hardware for the data center. But the problem was really one that was initiated by Meta, or Facebook at that time. I'll just say Meta now. So they were buying hundreds of thousands of servers, and as anybody that's on the customer side kind of knows, you don't necessarily want to be beholden to your vendors for forklift upgrades. And they figured out that there's a better way that they can design their servers. They said that they wanted to design their own servers and effectively did just that. And then said, anybody that wants to build these servers for us, we're going to buy hundreds of thousands, millions of these things. And because they were effectively open sourcing the hardware design for the server, they needed a place for that. So the OCP Foundation was born as a nonprofit to steward the community. And, in that 15 years, the scope grew from the server to open source network switches to storage specifications. And the community, now really is responsible for specifications across the entire spectrum of all different kinds of data center technologies. We say from grid to chip, or even concrete to chip, like literally the very, very foundations of a physical data center building. People are collaborating on open specifications for those, all the way from that kind of technology into the data center, all of the mechanicals, the electrical, the water, the cooling, everything inside of the rack, and down even to chiplet intercommunications and chiplet design and test and validation. So, right down to the semiconductor level. It's grown to thousands and thousands of engineers. And one thing that a lot of people often think about the foundation because we do have members. You don't have to be a member to participate in the OCP community. Part of its success is just free and open for anybody to come and collaborate.
So is it fair to just kind of think about it as sort of a supply chain specification marketplace for hyperscalers?
Yeah, that's one thing I didn't say. So, the benefit of these open source designs is that multiple vendors implement them, and this really fosters this multi-vendor ecosystem of, effectively the hyperscale innovation. The actual community tagline is community-driven hyperscale innovation for all. So obviously those innovative specs get adopted by the hyperscalers, but they're open for everybody else to benefit from as well. So yeah, we see certainly the neoclouds and down into the enterprise and smaller cloud SaaS companies, for example.
Our tagline at Hedgehog is network like a hyperscaler.
Yeah.
And our charter, at least from inception, was to do exactly what you just said, which is to make it possible for everybody to network like a hyperscaler. And you mentioned neoclouds and enterprises. So is OCP relevant for a neocloud or an enterprise, or is hyperscale just too hard and they just have to accept that, no, I don't have the talent to do this, and so I should really just buy vertically integrated solutions that are proprietary from a particular vendor, like your former
vendor at Universal? First of all, even if you're buying vertically integrated solutions, there's a very good chance that there's tons of OCP specified technology in it. It's almost impossible to build IT systems for the data center without stumbling across implementing specs that are in the OCP. But it's a good question, right? The hyperscalers come across the hardest problems first, and that's why the tagline is what it is. But of course, everybody can come together, and a lot of people use the community by simply being an adopter. Maybe those enterprises or the neoclouds don't have the resources, don't have the staff to do a lot of like volunteer work or to open source things, but for them to simply adopt the technology or effectively passively benefit from it is absolutely fine. So whether you're just trying to keep your ear to the ground, maybe to see what's coming around the corner in terms of technology, you might participate as an engineer in the projects. Or if you're just like a buyer, you might just prefer to buy stuff that's OCP specified or like OCP accepted, and recognized equipment within our OCP Marketplace catalog. Because you then have the evolvability of your infrastructure, right? Because it's based on open source, that there's plenty of vendors that are behind that.
Yep. And so you mentioned OCP Accepted. What does OCP Accepted mean?
Yeah, so I just mentioned it in passing. So to kind of back up and actually talk about what it is. So the way that the community works, right, is the engineers kind of work, I say upstream in projects and work streams, various areas on the data center technologies, and they work together to collaborate on white papers, reference architectures, and specifications, right? And then those specifications are implemented by vendors, of course. And when they are, those vendors are allowed to list their products in our OCP Marketplace. It's a catalog, but it's not a place of business. It just redirects, into whoever's vendor's website or their product pages. But it's a nice way that people can find OCP recognized equipment. So anybody that has something that adheres to an OCP spec, and we've even kind of loosened it at this point, any products that effectively align with an OCP white paper, perhaps, those things can get the OCP accepted badge and sit in our marketplace. And our marketplace also includes more integrated solutions as well. We might talk about that later, as we probably talk about the Hedgehog.
Yeah, we'll talk about it. Okay, so if I've got something I want to contribute to the community, I want to be in, to have that solution in the OCP Marketplace. What's the process for getting it accepted for a reference architecture in particular? Because we're going to talk about reference architecture.
Yeah, exactly. So the reference architecture contribution, or any contribution to the OCP, goes through a standard process. We've got a few staff that help people through the process, and a lot of it's automated. But you sign the contributor license agreement, which is Open Web Foundation, I think 0.9 agreement. OCP doesn't acquire any intellectual property as part of that. It stays with the contributors. But they do sign that saying that, it's effectively going to be opened and cataloged, I suppose, in the OCP contribution database. Then there's obviously, if the work has already been done, it gets presented within the relevant project at OCP and then gets presented to the steering committee. The steering committee is basically one representative on that committee per project. So it's a group of experts across the data center and obviously technical experts. And they, in turn, with our principal engineer at OCP, Russ, they basically make sure that the specification looks good. And once they rubber stamp it, then it's free to go into our contribution database. And at that point, then anybody that builds a product that uses that specification, they're eligible to have that product in the OCP Marketplace. So the contribution database and the marketplace kind of, upstream, downstream of the same overall process.
Cool. Awesome. Okay. Thanks for that background. So I want to shift to the topic of, it's a hot topic right now. It's disaggregated inference. What is disaggregated inference and why is it important to the future of AI?
Yeah. So, fundamentally, the servers aren't necessarily ubiquitous anymore. We have known about these, the difference between training or pre-training and inference for a long time in the AI conversations. But over the past year, with these specialized chips, right, whether it's like Grok or Cerberus or others, more and more we have specialization within the inference workload. So, if you are, for example, uploading a document to ChatGPT or Claude, you're providing a ton of input tokens. That's part of the prefill phase. And then actually where you're getting a lot of output tokens, doing the work, doing coding, whatever have you, as part of your request, your prompt to fulfill it, that's basically invoking the decode phase. There's different performance characteristics that be optimized for there. So pulling apart the hardware architecture to match those two different phases is what the disaggregation is effectively doing with different memory technologies and different accelerators or GPUs, XPUs.
Got it. So the general idea is that I use two different AI accelerators to get faster, more efficient inference. Is that
exactly? Yeah. One for the prefill, one for the decode. Better performance.
So then that means really that we should expect AI cloud builders going forward to have more and more diversity in their data centers of different AI accelerator types, right?
Yeah, absolutely. There's a whole bunch of reasons driving diversity. So part of it is what we just talked about, disaggregated inference. Obviously, people that are doing training and inference may do that on different platforms. When you hear about the frontier models getting released, you'll often hear like, oh, such and such, like ChatGPT 5.5 was trained on Hopper, but then it was sort of like tuned on GB200. So there's things like that. And obviously they'll have different infrastructure for inference to run it and optimize for prefill and decode. Besides that, I think, GPU infrastructure is not going away as fast as people thought it was. There's still a lot of, A100 stuff around that people are not decommissioning because at this point, there's so much demand. There's so much more demand than there is supply.
Right.
And then obviously, AMD with their chips are coming along, getting deployed massively. There's tons of announcements. Obviously, we heard NVIDIA acquired Grok and going to be deploying that. Jensen's last GTC was showing 5 different racks, 5 different types of racks that basically constitute an AI factory. So even if you're only deploying NVIDIA accelerators, you're still deploying lots of different generations and lots of different variants.
Yeah, and I think we saw Cerebras IPO last week.
Yeah.
IPO price was, or valuation was, just under 100 billion. I think only Meta and Alibaba have exceeded that in IPO prices. That's an example as well of an XPU that might be in an AI data center alongside NVIDIA GPUs. Yeah.
Yeah.
Cool. Okay. So then that leads me to the next question, which is the OCP Open Clusters. There's a specification for open clusters. There's another specification for open pods. What is a cluster? What's a pod? Why do they need to be open?
Yeah, so pod is basically a building block of a cluster, right? And a cluster, for most people, it's the distributed but acting as one computer for potentially a single problem. If you're training on a cluster, you often using the entire cluster. Otherwise, the cluster is basically your infrastructure that may be used for different workloads. Obviously, if you're somebody like a hyperscaler or a neocloud that's providing that as a service, then you've got multi-tenant concerns on that shared infrastructure, and you're selling it up, dividing it up and selling it. So I think what a cluster is well understood. Pod is a building block of that. People think of even a sub-element of the pod as sort of the scale-up domain, I suppose. But to answer your question about the open bits of it that have started within the OCP, I mean, OCP traditionally, people built specifications for specific point technology needs, like a server or, a disk drive or, a power supply, all these different things. And one of the hard problems that people were facing when they're trying to build AI clusters is that they're, reinventing the wheel, solving the same problems again and again. And there's no point of designing a snowflake for every AI cluster. So a bunch of collaborators created a project, or specifically we called it a strategic initiative, I guess, within the OCP. And it's got a long name. It's a mouthful: Open Cluster Design for AI. And they created a specification for pod, and the pod is a building block for the open cluster. So they've effectively open sourced an architecture or design of how to build in a pod multiple racks. They actually started with air-cooled and 400 gig connected racks. Now they're working on liquid-cooled 800 gig scale-out connected racks. And there's a specification for exactly how that pod is designed, so that everything from all of the cables that you would need, the number of racks, the exact number of compute and accelerators within that. And they try to do it in a way that multiple vendors can kind of slot in and fill the different roles for like servers and switches and racks. Obviously, wherever they can, they base those decisions on other OCP specifications. But yeah, now somebody can take that and build an AI cluster from it. So it's basically everything that's on the IT side. It doesn't include like the OT reference architecture, like, how to build your floors or how to build your overhead designs and space like that.
Yep.
But in terms of the row layout of multiple racks and everything within them and how to connect them, how to configure them, that's basically what it is.
So if I want to build an AI cloud that, say, has NVIDIA GPUs, AMD GPUs, Google TPUs, maybe some Cerebras accelerators, each one of those accelerator types or XPU types would have its own pod, and they'd all work together in the same cluster. Is that kind of the general idea?
Yeah, I suspect that most people would probably deploy them in different pods. When it comes to the disaggregated inference bits, I suppose you could have, the prefill and the decode kind of working together. They could be deployed in a single pod. At this point, the architecture doesn't have that in its specification, but because that prefill decode disaggregation is a fairly new idea, right? I think it's less than a year old.
Yep. So let's get into prefill and decode for a minute. Let's assume I'm using multiple accelerators or different accelerators for the prefill and the decode code. They need to share memory, so they need remote direct memory access on the network. Is that going to work if each XPU vendor shows up with their own proprietary, vertically integrated network stack? And I guess the second part of that question is there a reason to have an OCP reference architecture for OpenAI networking that enables those diversified clusters to interoperate?
Yeah, well, I mean, to go back to one of the words I said before, evolvability is really important, right? So, the answer is not really. You may start with a network that might work today, but as soon as you start adding like different accelerators, if those vendors have different opinions on what networks you should be deploying, that's kind of a non-starter. You want your infrastructure to be able to talk to each other. So obviously the prefill, the decode infrastructure have to be able to talk to each other to work together for a common inference workload.
Right.
So that's absolutely true. But there's other times when you'll have infrastructure that you just simply want to all work together. And the network is what stitches everything together, right? There's the old saying, the network is the computer, and that's especially true for AI clusters. So it's a non-starter for you to have different, silos, so to speak, in your network. You want your network to ubiquitously connect up whatever you decide to deploy next.
We're just a few weeks past the OCP EMEA summit, where Hedgehog announced our contribution for this OCP reference architecture for AI networks. There's actually 2 RAs, one for training, one for inference, and you and I were on a panel talking about it.
Yeah.
So if somebody listening to this show is an AI cloud builder and they want to find those OCP reference architectures, how do they find them?
They're in the OCP contribution database. I mean, an AI query or Google search would definitely turn them up, I'm sure, as well. But a prominent part of the OCP website, opencompute.org, is the contribution database. You can go to opencompute.org/contributions. Because they're fairly new, they're probably sitting right at the top. But if you typed in, reference architecture, you'd find them very, very quickly. Also, there's ways to sort of like filter things by what project and initiative they fall into. So that Open Cluster Design initiative that we talked about is kind of what these specific reference architectures you guys contributed are tagged under.
And so I think at the same time at that show, you also had a contribution from OpenAI on MRC, right? For like really big training clusters. Can you talk about that a little bit?
Multi-path reliable connection. Yeah.
So sort of another method of building an AI network for really large training clusters.
Well, I mean, it's a host-driven protocol to optimize and to allow for the network to be, a little bit dumber, so to speak, or to allow the high performance needs and the optimizations that you need in a AI backend network without implementing all of those optimizations in the fabric itself. Again, because you want your fabric to effectively be ubiquitous, to be able to connect up whatever you want. So yeah, OpenAI, Microsoft, AMD as well, for that matter, and NVIDIA, I think, and Intel work together on the MRC spec. Yeah, so I mean, that is an example of a spec that's a PDF in our contribution database. The reference architectures you guys contributed sit in GitHub, right? Mm-hmm. And I know that in the panel, we saw like people can create one of those reference architectures in a virtual way too. If they don't even have like their cluster today, there's ways that they can play around and actually see what it would look like.
So James, you're like in a really interesting position where you just have visibility on what, the world's biggest hyperscalers are doing, what the world's largest infrastructure providers are doing for those hyperscalers, for neoclouds, for enterprises, across sort of all the different layers of the AI infrastructure stack. What's coming in the future? Like, what are we going to be talking about next year at OCP Global Summit, and what should people be thinking about?
Well, I mean, so some of these things will absolutely see continued adoption of them. So we absolutely love having adoption. We have a whole adoption track at all of our OCP summits. So hearing about the success stories of these things getting deployed, you know, Open Rack Wide was announced at last Global Summit, and the specifications available. But I know we're going to start seeing Open Rack Wide, you know, flavors from, you know, all of the usual suspects, right? So the Helios from AMD, from HPE, there'll be some from Supermicro, I'm sure. So, you know, those are the double wide racks that people are talking about. Again, and those scale up domains have a scale out that needs to be compatible with everything else that you're deploying, right? You're not going to deploy ubiquitous Open Rack Wide. You're going to deploy that with GB 200, 300 racks, VR racks in the future from NVIDIA, and then, probably some Cerebras, et cetera. So I think you're going to continue to see an expansion of the flavors of AI infrastructure that's deployed. Hopefully, we're going to see some hardening of the decisions on the facility level so that the facility can be a little bit more fungible for these sort of, like, as the open letter at OCP says, late binding decision making on all of the evolving IT specifications.
You're talking about the OT that houses the IT, right? Is that what you're talking about?
Yeah, exactly. Yeah, a big part of the OCP that is sort of, not my wheelhouse. So as you introduced me, I have a network walk, but learning about everything that's happening in liquid cooling, whether it's, cold plate or immersion, whether it's single phase, two phase, all of the stuff that's happening for low voltage direct current at 800, or, they're talking about how do they go to 1500 in the future. We just had a workshop on that. So seeing the new busways and bus bars for some of this higher voltage, but still LVDC stuff is fascinating. So I mean, there's things happening all around. If you're on the networking side at OCP, there's a brand new optic circuit switching project for OCS. There's tons of stuff happening to try to drive more stability and reliability of the optics. At a new work stream there.
That one bites us all the time.
Bites a lot of people all the time. But when you're deploying millions of these things, it turns out that if you have even a small number of them that are faulty,
reliability is a huge issue in these huge clusters, because there's thousands of moving parts. So I woke up this morning, checked my email. I had a survey request in my inbox from OCP asking if you should move the location of OCP Global Summit. So I went last year. It's at San Jose Convention Center. Of course, we go to NVIDIA GTC every year. I think OCP Global Summit last year was the only show I've been to. And we do a lot of shows, like probably 2 a month, that felt as big. It's not quite as big, but maybe number 2 to NVIDIA GTC. Is the community growing? And is it too big now for San Jose?
It's growing. It's growing massively. Some data points on that. So the recent contribution for LVDC was the most collaborative contribution we've ever received. It had like 70 different companies and hundreds of people that worked on this. Amazing. Obviously, I said, the OCP has grown in scope to all things data center. And with that, all of the OT vendors and solution providers are joining OCP. That's another way that OCP is growing massively. But although a lot of the work happens virtually in projects, on calls and mailing lists, one of the ways that everybody comes to know OCP is by coming to one of the summits, the conferences. And the biggest one is the Global Summit. It happens every October. And it's happened in San Jose every October at San Jose Convention Center. But it's getting to the point where we're, busting at the seams of the convention center. We were over 11,000 people last year.
Yeah.
We were over 11,000. We're probably going to be 13, 14,000 this year. So we're approaching, GTC levels. I don't think we're going to have the Shark Tank for our keynotes, but
it's pretty tough. I think Taylor Swift's probably the only person on the planet who could top Jensen in a keynote. Yeah. Well, James, thank you so much for talking with me today. Thank you so much for being a part of the OCP community and welcoming Hedgehog into it. Honestly, like when I first started thinking about this problem space that we're solving at Hedgehog, I was still working at Cisco, and I was talking about it with my boss. He's like, just what you should do, just go to the OCP Global Summit and check that out, and then come back to me and report on open networking. Yeah. So that was really the genesis of Hedgehog, was attending that event, and I'm forgetting now how many years ago. It's a long time ago now, but we've been to every single global summit since, and they're fantastic events. I encourage everybody listening to this to go to an OCP event, be it global summit or one of the regional summits, because I guarantee you will learn a ton about AI infrastructure, which is a growing community for a very rapidly growing market. So thanks, James.
Yeah. Thanks for having me. It's a pleasure.